Hello everybody, my name is Jonas Pilz. I work for Maxon in the marketing department, and today I want to show you the new stuff in Cinema 4D Release 20. Okay, I will make hands-on only, so there will be no keynote presentation or something. It will all be live inside of Cinema 4D. Okay, the first feature I want to show you is the CAD import. And the CAD import is really something I was looking for a long time, because I worked in production before I started working for Maxon 3 years ago. And I had a lot to deal with CAD data. And it was always painful to get CAD data into Cinema 4D. We always had to use third-party applications. And this is not the case anymore, which is brilliant. And now I will show you how easy it is to import CAD files into Cinema 4D. So here I've got this step file, this front wheel assembly step file, and I will just drag and drop it into Cinema 4D. I release the mouse, and here are the step import settings. So we have some stuff regarding general import settings, like what should we import and in what size. So we can also import instances, for example, which is really cool. And here are some options, mostly regarding shading, but also other stuff like how to handle the layers, but also the display colors. How can I create materials like based on the display colors or random colors and so on. Here we can adjust modifications to the geometry, so we can have no modifications, but we can also combine everything by the original body. So whenever two parts of a CAD file touch each other, those will be merged. Oh wait, this was topology. Original bodies is of course the original bodies. What I told you was about topology. Then you can also combine geometry by color. And you can also combine geometry by layer. So if you have layers enabled in your CAD file, then everything will be merged in those layers. Okay, you can swap the Y and Z axes, which is also really cool because CAD files or CAD applications normally have Z pointing up and not pointing to the side. You can heal and stitch, and you can also optimize the hierarchy, which is really cool because it reduces the amount of objects that are imported. And you can handle the tessellation. But let me show this to you by simply clicking OK here, and this will take just a few seconds. And as I speak, the whole object will be tessellated in the background. And once this tessellation process is done, it will show up. So now it creates the scene, and here we go. So this is the CAD file we imported. Let's have a look at the geometry, at the tessellation. So this has already some homogeneous tessellation on, because it was enabled in the settings. And if we unfold this here, you can see that there are polygon objects. You have just one null per group, which is really good because my experience with other third-party conversion tools was that there were several nulls and you had to clean up the whole scene. This is not the case with our CAD import. We have got the instances here, so whenever there is a screw or something, this has to be there just once, and all of the other screws will be instanced, and so on. So maybe let's import this again and adjust some of the settings, like the tessellation here. So I go back to the Finder and just import it again. Yes. All right, let's go down here. So what I had enabled was the max length of an edge of 10 millimeters. And this is why we have this tessellation here. By default, it's at 0. And if I import this object again, you will see how it looks like with the original tessellation. We have to wait for a few seconds, and there we go. Let's enable the mesh. So this is what would come in by default. So it's clean topology, it's all triangles, but as you can see, it's really nice and clean, and you can adjust all of the other settings if you want to. So let's import another CAD file, which is IGES. So by the way, we support 5 new formats, or 5 formats with this CAD import, which is STEP, IGES, JT, CATIA, and SolidWorks. These are the formats that work in R20. And now I will import the bicycle here. Maybe let's just create some materials based on the display colors, and just press OK. If you notice it, the maximum length of the edges was set to 10 millimeters again. So we will have a homogeneous tessellated mesh here once the bicycle will be there. And just a few more seconds. It's creating the scene right now. And there we go. So this is our bicycle. Look at this. It's really cool. And yeah, as I told you before, I think that this is one of the most important features for a wide range of users, because everyone who has to deal with CAD data can handle the CAD data inside of Cinema 4D or import it into Cinema 4D without the need for a third-party application. Okay, so let's create a new scene, and we will also go to the next feature that I want to show you, and therefore I will also change the layout from startup to motion tracker. So this is the motion tracking window, or the motion tracking layout. You see that it's new, and we want to import something, and I want to show you the new features. So first of all, we've got new stuff here. First, there is the motion tracker track view, and it says double click to create a motion tracker object. I will do this, double click, and here is the motion tracker object, and I double click again to select the footage, like so, and I will use the object tracking box here. So this is some footage I shot for testing purposes. Maybe let's reduce the length of the video here and just hit play once. All right, there are a few things that are new. First of all, the motion tracker track view, but also in the 2D manual tracking section, there is a new user tracks list. And this is very important because this list is like the workflow base for manual tracking. So let me just create a new track, and then we'll see what we can adjust here within the list. So first of all, we can adjust the name directly here, bottom. Okay, you can also adjust the size of the searching and the pattern area here. You can also do this here with dragging and dropping the handles here. You can adjust the color filter down here. So if we want to track the red channel, for example, you have a visual indication that we're tracking red. We set it back to luminance. You can lock separate tracks, and you can set them to track in a circular pattern. Okay, now let's just track this by hitting this button, and let's go further. And you see at some point the track is lost. But we also have some remedy for that. Let's go to the motion tracker graph view, which is a little bit big here. We will scale it down and scale up the tracks themselves. So one thing that is new, that there is a visual indication for the tracking direction. So this is the keyframe I set at frame 0, and then we've got the arrows that point to the right, which means it's tracking forward. But you also see that the track has good quality in the beginning, and then it turns red, which means the quality decreases until it loses the track completely. So what can we do about that? There's an exciting new feature in release 20, which is called virtual keyframes, and I will unfold that and activate it. And as I activate it, you see that something happened to this area. I will deactivate it again and activate it again, so you see the difference. And there is something new, which is these blue keyframes. And those keyframes are the virtual keyframes, which means depending on the mode, Cinema 4D or the tracker will set keyframes, internal virtual keyframes, in order to keep the tracking good. So there is an error threshold, and as you move a pattern, or as a pattern like this changes, this error threshold will be reached or exceeded. Right now, the mode is error threshold preemptive. Let's set it to exceeded, and then you see that the whole thing is tracked now. So we lost the track before. So here we have a red keyframe, but have a look at what this did. Here it loses the track, sure, because there is nothing to track anymore. But this works quite well. So with less manual effort, you can track more complicated things. And these virtual keyframes are extremely helpful when you track patterns that are rotating, like this pattern here. You can see this here in the motion tracker track view. Okay, let's set the mode to frame interval. And now the frame interval is set to 10. And you see that at every 10th frame, there is a virtual keyframe. Okay, maybe let's set some more keyframes here, or let's create them. And you see that we have got that the tracks appear here. And what you can do now as well is you can right-click here and create a new folder and rename the folder bottom, for example, and then select the other tracks and make them a child of the bottom folder, which means you can now really organize all of your tracks here in the list. And you see all of the changes that you did to the tracking itself. So if you want to, or if you tracked some color channel, or if you use the circle here, or if it's locked, so you can do this like with any of those tracks separately, which is really cool. So let's go back to the first tracker we created, because I didn't show you the motion tracker track view yet. So basically what this does is it keeps the track in the middle and moves the footage around the track. And this way you can really see if your track is accurate or not. So it's much easier to do that in comparison to this one here, where you don't really see what's going on. So there are some other cool things that have been changed, like, for example, the masking tools. If I create a mask now, let's do this. So with just a few points, I create a mask here, and then I move a few frames forward. And what I can do now, which wasn't possible before, is I can use the rectangle selection, for example, and select all of the points here, go to the move tool, or to the rotate tool, or to the scale tool, and just scale, rotate, or move the mask as a whole. All right, so these are the most exciting new features to the motion tracker, in my opinion. So there is a huge benefit in the workflow right now. You're much faster, and the tracker takes some of the efforts which would have been manual work before. All right, the next setup. Let's create a new scene. And let's go back to the startup layout. All right, the next thing I want to show you is the node-based materials, and these are really exciting. So first of all, let's create a scene with a plane and a light maybe, to have some simple setup at least, where we can see our materials in action, so to speak. All right, this is our scene, and now we want to create a node-based material. To do so, go to Create, New Node Material in the Material Manager, and there you go. This is a node material. Once you double-click the node material, you see the node editor popping up. Okay, so maybe let's make this a bit smaller, because the first thing we want to do is we want to import a texture here, and therefore I go to the content browser and search for a texture. Maybe the wood texture here, and just drag and drop it into the node area here. This also works from outside Cinema 4D. So if you select, or if you drag and drop an image from the Windows Explorer or from the Finder on macOS, then there will also be a new node. Okay, so this is a very simple concept, but you can create very complex stuff with it. So nodes are very small pieces of functionality, so to speak. So every single node that you can also find here in the assets section provides you with some small piece of functionality, and you can wire them up in this nodal workflow. So you have a node with input ports and output ports. Some of you might know this from Espresso already. And once you connect two nodes, for example, the result node of the image here to the color input of this diffuse layer here, you can see that the wood texture is now on the material here. Maybe let's also assign the material to the plane here. And yeah, maybe let's also just create some more functionality here. I zoom this down a bit smaller. And one of the advantages of a node-based material, or of node-based systems in general, is that you can use an input for, or an output of some node for several inputs in other nodes. So for example, I can use this texture not just to control the color of the material, but also to control the bump, for example, and also the reflectivity or the roughness of something. And this is what we will do next. Okay, so first of all, we want to create a new node. I want to create a node setup to pipe this texture here into the normal input here or there, but as a bump. Okay, therefore we need a grayscale image. So let's create a color correction node, which you find under color. So here you've got the assets section, and there are a lot of assets here. I think it's more than 150 in total. And those are the nodes that you can combine. And by combining those amounts of nodes, you can create almost everything that you can imagine. So let's create a color correction node simply by dragging and dropping it into the node area here. And let's use the output of this image node here as the input for the color correction. And here in the color correction node, I've got some settings. On the right side, you see the attributes manager, and let's bring down the saturation. So now in order to connect the color correction here, or the black and white image, which is the result of this color correction node, to the normal input here, we need another node that converts this bump map that we created here, that converts that into a normal map. And therefore, there are some surface nodes, and within the surface nodes, you see a bump map node. So let's create this, and here I show you a small trick. Once you create a node directly on a port, this node, or the new node, will automatically be connected to this node. And now you see that we created a normal map out of this bump map here. And this can be wired with the normal channel here. Now if we have a look at the rendering here, maybe let's make the window a bit smaller and let's hit render once. Then you see that the bump is quite strong. So let's bring it down, bring down the strength to something like 2% or so, and let's render again. Maybe this was a bit too much. And maybe let's bring it up again. Yeah, now we can see it. Okay, so what we are doing now is we use this one texture to drive the color as well as the bump. And whenever we adjust the texture here or replace it, the result of this node will be piped through all of the other nodes, and it will create the color and the bump automatically. So now here's the next thing that we can do. The whole node-based material system is based on the reflectance channel. So we've got all of the reflectance layers. This is the diffuse layer here, and we want to create a new layer next. So in the material node here, we can add a new node. And when we click this triangle button, we can go to Surface BSDF, which is basically a node for all kinds of reflections. Let's place this here, and let's set the type from diffuse to be Backman, which is a reflection, or a real reflection like you would imagine it in the real world. And let's also set the Fresnel from none to be dielectric, because we got a wood material and not a metal here. And yeah, this is the same as we would have two layers in the reflectance channel, like one diffuse layer and one Backman reflection layer. So maybe let's drive also the intensity or the roughness using this one material here, or this one image here. And therefore, we need to convert it into a black and white map, basically, because this way you can also steer the intensity and the roughness. Okay, let's use another node for this now, which should be the gradient. And I want to show you another trick. If you press C in the node-based materials, the node commander pops up, and you can search for any kind of node, like for example, the gradient. And we will use the basic gradient here. And let's see what this gradient offers to us. There is a position input. And by using this position input here, you can use the whole gradient node as a colorizer. So let's pipe the result node here into the position node of the gradient, and you see that there is a black and white representation already. But the cool thing here is that we can bring up the whites by bringing the white knot here to the middle, and you see the whole image brightens up. And you can also colorize these knots, which is also very important, because what you can do with color is you can drive other parameters, because color is nothing else than a value. And if you have black, it's just a 0, and if you have white, it's a 1. So black is 0% and white is 100%. And if you pipe that values into the intensity, for example, you can drive the strength or the intensity of that reflection by using the image here. Okay, we could do the same thing with the roughness, but I want to continue here. And I want to show you how you can group nodes, because node setups can get quite complex in a short amount of time. So maybe let's select all of them, and by right-clicking, you can choose the command group nodes. And once you do that, you have the wood texture left because I didn't select it, and this is piped into a color input of a group. And maybe let's open the group, and this can be done by clicking this icon here. Here we've got everything that is inside of the group. So we've got the input to the group here. This is what is exposed to the group, what you can see here. And maybe let's some other inputs as well, like maybe the strength of the bump map. So we can just use this and drag it over to this section here and just drop it. Add input. This is the strength of the bump. Maybe we should rename it to bump strength. Bump strength. Oh, we can leave this. Okay. And maybe let's also expose the roughness here. So we use the roughness and bring it to this section here, add the input, and now we've got color, bump strength, and roughness. Here on the right side, you can already see how your interface will look like. And once you leave the group, you've got these parameters here. So the cool thing about node-based materials is that you can create materials that only have those parameters exposed to the user that you want to expose to the user or that the user needs, but nothing more, nothing that confuses the user. So if you have like a technical director in your company, this guy can be used to create complex node-based material setups, but then in the end, he can expose just a minimum or the necessary parameters to all of the other guys that might not know how to create a node-based material setup. Okay, so now that we have this group node here with these 3 parameters, let's see how we can make this the material interface. Because if I close the node editor and double-click the node material again, the node editor is what pops up. But if I select this group node here and set it as a start node, then this will be the node with the inputs exposed to the material manager. So it gets a green outline. This way you always know this is the start node. So whatever inputs this node has will be exposed to the material interface. So let's close the node editor again, and let's double click the node material here. Oh, sorry. This opened up on the other screen again. And you see that now this interface of that node is exposed to the material editor. And now you can add an image here or adjust the bump strength or the roughness. Okay, If you want to adjust the node setup further, you can still go to the node editor and make some changes. So maybe let's go inside this thing, and although it doesn't make sense for now, let's just make an input for this intensity here, add input. Let's leave the group, and you see that there's the new intensity parameter here now, and this intensity parameter is automatically exposed to the material editor. So this way you can create complex materials with an easy interface, and this is exactly what we also did, because we thought not everyone wants to deal with nodes, so let's create a material that is just like our other material system, but with the same, but with the power of nodes in the background. And this is the new Uber material. So let's create one of these, and let's double click, bring it to the right screen. And here you see that there are all of the parameters that you know from the other material system, but the base of this one is the node-based materials. So this is completely created from nodes, including the whole interface here with the checkboxes for the separate channels and so on. So another thing you might want to know is, how can I create a material here? So what you can do is you can also, like in the node-based material, just drag and drop something to the color input here, like this image, and now this image is driving the whole color. If you want to color correct these, you can add a converter node, which could be the color correction. Then you go to color correction and just bring down the saturation or whatever you like. So this is the Uber material workflow here. But we created a few other presets for node materials, like a car paint material, ceramic, concrete, a cutout material, an emission material, gold, and so on. So there are presets for several things here. So I hope you like that. We have to carry on, because otherwise we're running out of time. The next thing I want to show you is the enhancements for ProRender. Okay, let's create a new scene, or let's see what kind of scenes I have here for ProRender. There we go. The action cam. So this is an action cam scene. And maybe let's go to the render settings first, so I can show you some of the new stuff here. Let's go to the ProRender settings. And the first thing you see is that there is motion blur, which I will show you in another scene. And there is a new triangle here next to the max ray depth. So what you can do now in order to save render time is you can set the ray depth for separate ray types, so to speak, separately. So you can adjust the diffuse depth, the glossy depth, the refraction depth, and the glossy refraction depth, and also the shadow depth. Keep in mind that the first one here is the max ray depth. So this parameter will limit the other ones. So once you bring this up, this will have no effect, because here the highest number is the refraction depth with 12. Once you bring it down to 11, for example, all of these parameters will be reduced or will be limited to 11. In this case, it's just the refraction depth that has that was adjusted here. But if you bring it down further, like to 7, everything here will be set down to 7. This is something you need to keep in mind, that this is just the maximum ray depth, and this is there to limit the other ones if you want to create a quick render or whatever. Then another thing we have now is multipasses. This is a huge step in making ProRender production ready. So maybe let's enable the render multipasses, and yeah, let's just hit render and see what comes out here. So right now the whole scene will be shifted or moved to the graphics card's memory, and once it is there, it will start rendering. It takes a short amount of time, but once it's there, it will be quite fast. So there we go. I just limited to 10 iterations in order to save time. And let's go to the layer section here. And if we go to single pass, we can see that we rendered the indirect illumination, the direct illumination, an object ID pass, a shading normal ID pass or shading normal pass, and the world coordinates. So yeah, there are several more, like emission or the depth, whatever you want. You can also choose to set anti-aliasing for some of the multipasses here whenever it makes sense. Okay, and yeah, the next thing I want to show you is subsurface scattering, because subsurface scattering is part of ProRender inside of Cinema 4D Release 20. Therefore, let's go to another scene, subsurface scattering scene, where I reduced a scene from the content browser. Okay, and here we've got some raspberries. Maybe let's start ProRender here to see that the subsurface scattering effect is already working. So here we go. A nice subsurface scattering effect here. And once we go to the raspberry material, you also see in the luminance channel, if we hit the subsurface scattering preview in order to open it up, that this is a completely new subsurface scattering shader that is optimized for ProRender. So what we have here is we can set the scatter color, the depth color, and also some, if the material is transparent or if it should emit light and so on. So this is a completely new shader. Yeah, for now, you can see that subsurface scattering works quite well here. All right, and let's directly jump to the next thing I want to show you, which is motion blur. And therefore, I prepared another scene. Which is a carrot. And now I want to explain to you first that there are two types of motion blur, and therefore I created two types of animation. So if I hit play here, you see that first the whole carrot is moving to the left and rotating and then back, and the second one is a deformation of the object. And this is important because not everything is supported by all options for motion blur. So first, if we have an animation like this where we are just adjusting some position, or where just the position and the rotation and the scale are animated, then you can use linear motion blur. So let's open up the render settings, and in the offline render settings we've got the motion blur parameter, and let's set it to be linear. And if we hit render, you see that there is some motion blur going on. You see that it also recognizes the rotation. Here it's blurrier than down here. And it's also calculating 100 iterations. It's quite fast, but the problem with linear motion blur is that it's limited to cases where an object is moved with the translation translation parameters like scale, rotate, and move, or position. Okay, so here we've got the animation that is a deformation of the object. And if we hit render here, you will see that there is nothing blurred here because linear motion blur doesn't see object deformations. This is valid for character animation as well, or if you have some motion graphics animation where you just animate the surface of an object, then you would need to use subframe motion blur. Okay, so let's set this from linear to subframe motion blur. And if you don't know how subframe motion blur works, basically it renders a frame including subframes for several times. In this case, for 16 times. So in between this keyframe and that keyframe, it will create 16 subframes, so to speak, or 15 subframes, and will blend the result together. So as you can imagine, if I leave the iteration count at 100, this will make the render time 16 times longer than without motion blur, which is not really productive. But what you can do is you can counter this samples amount here by dividing the iteration count through this number. Well, just approximate this. So for example, if I bring that up to 36, for example, you can bring down the iteration count to 3 because 3 times 36 is something that is a bit bigger than 100, 108. And yeah, let's hit render. So we've got 108 iterations now in total, but those are distributed through every subframe. So every subframe is rendered with 3 iterations, but the whole thing is rendered with a total of more than 100 iterations. Which means that the image is not as noisy as you would expect it of a 3 iterations rendering. But if you watch closely, but I think no one will recognize, once the image is ready here, then you will see that the noise appears in these areas here. So first of all, you see that there is no motion blur down here because there is no movement going on, but in the areas where there's a lot of movement going on, it works even with deformations or with everything inside of the scene. Also, camera would be blurred, or the camera motion blur would be there. Yeah. So just for you to notice, you can counter subframe motion blur by reducing the amount of iterations. All right. So let's move on. The next feature I want to show you, which is quite exciting, is multi-instances. Let's use another scene for that. Multi-instances. And we open up the crowd scene I prepared. So this is a basic crowd scene with some of the people you can find in the content browser. You can see that there is a ground and they are rendered with shadows. So now let's increase the whole amount of clones, or in this case of persons. We go to the cloner and increase this to 10 by 10 people. So now you see that there is already some frame rate dropping here because the models are quite complex. And I think each one comes with around 70,000 polygons. And maybe let's also set the clones to random here. So we've got some randomization going on. But you see that everything takes quite long. And this is because we are rendering, or we are creating just normal MoGraph clones here. Once you set it to render instances, which is the instance mode you know from before, render instances. It gets a little bit faster, but maybe let's increase that even further to 20 by 20 and zoom out a bit. Then you already see that the frame rate starts going low again. Maybe let's increase it even more, like this. So the effect is more recognizable. So what you can do now is you can set the instance mode to multi-instance. And normally the mode is object here. This is the default. I just adjusted it also in the preparation for this webinar. And you see the frame rate is a bit better, but you also see that there is this viewport modes, and you can adjust them. You can adjust the clones to be bounding boxes, for example. And once you do that, you see that it's fluent again, completely fluent. So maybe now let's create some random effector to add some randomness. We want to affect X and Z, but not Y, to reposition them, and we want to randomize the rotation as well. So this is our setup here. Once we render, you see that these bounding boxes here will be replaced with the real people. Okay, right now we have 30 by 30 people. Maybe let's increase the amount here. Maybe let's bring it up to 100 by 100, which is already 10,000 people here. It's still fluent, as you can see, and you can also see where your crowd is. You hit render, and of course there is some short preparation time here. But with multi-instances, you can really fill a place or a square of in a city with people immediately. So I show you something. If you bring the viewport mode to be points, or if you set the viewport mode to be points, you can go even higher. And by going higher, I mean much higher. You see, this is the far clipping of the scene. And yeah, maybe let's bring the count up to 1000 by 1000. So what we have here in a second is 1 million clones. 1 million people. Here they are. And you see that we can still navigate here. And as we hit render, you will actually see nothing but a noise. But the people are still there. Maybe we can see them. Maybe not. Maybe they are too small, but they are there. We are rendering 1 million people with 70,000 polygons each. So of course, this takes some more preparation time than just rendering 10,000 clones. But yeah, from my preparations, I know that this preparation will take around 1 minute. But it's cool if you see it in the end, because now you can go really high on clone counts. And yeah, Cinema 4D can still be fluent in the viewport because we have these nice viewport modes down here. So here it starts rendering. What you see is just a noise, but actually this is 1 million people. Isn't that crazy? Okay, let's bring it down again, maybe just a bit to 200 by 200. To have it like this and render again. Now the preparation time is also much faster, and you see, yeah, here you can really see the people again. So this might help you a lot when it comes to architectural visualization or also for heavy MoGraph setups. or motion graphics setups. I think this is a really powerful feature because what we never could do really efficiently was to create a lot of clones, and now we can do that with multi-instances, which is really cool. All right. Yeah, two features left, two features that I want to show. So first, let's start with fields. And therefore, I created another scene that you might know from one of the feature videos. Fields. And this is, yeah, it's this one here. So just to tell you, what are fields? Basically, fields are separate objects that define a fall-off. So what you can do now, because they are separate fall-offs, is you can place a fall-off somewhere in your 3D scene, and everything that that supports fall-offs will react to that. So here I've got the spherical field, for example, and I also have this torus. And once I move the torus, you see that the rest here reacts because the fall-off is a separate object. Okay, another thing that is really cool about fields is they are not just separate objects, but they can be mixed in order to create very complex fall-offs. So in the effector, nothing has changed except for the fall-off tab here. And here you can see that we already have a field setup that consists of 4 fields: a solid field for the color, a spherical field, which is this one, a box field, which is this one here. So maybe I can rotate it so you see it better. So this is the box field here. And a vertex map, which just colorizes these areas here. So what you can do here is you can mix fields together. So this can be seen not as well, or not as good as the others. Maybe let's do this with the box field. So we have got blending modes, and we also have opacity control. Yeah, so this is the fields list, which is basically a bit like in Photoshop. So if you are familiar with the workflow in Photoshop, this is basically the same. The cool thing about fields is that one field can be used in several effectors. Like in this random effector, for example, it's almost the same field list, but what you can see is that the spherical field and the box field are part of both setups here. So once I move one of these fields here, you see that the plane effector reacts to it as well as the random effector. And this is a very powerful concept because what we have here is actually weighting tools that are unified across Cinema 4D, and I mean the whole application. So let me show you something else. A new scene with a plane. I will bring up the plane segments to 200 by 200. So it's quite dense. And I will make this editable. So now it's a polygon object. I go to points mode. And what I will do now is I will set a vertex weight or create a vertex map. And one thing you can do with fields is you can use them inside of a vertex map in order to control the vertex map. So maybe let's get rid of the freeze layer. The freeze layer would store the current selection, but we don't have one. So let's get rid of that. And maybe let's create a spherical field. And here you see that field is not just fall-offs, but it's also easy to use vertex map tools. And you've got a lot of fields. I mean, I didn't show them to you before, but This is the field objects. We got the box field, capsule, and so on. Everything pretty much that you had before in a fall-off tab is now a separate field. But you can also use a MoGraph object, particles, a polygon object, spline object, step, time, a vertex map, and even a volume object. And then you also have layers to modify the weights you created. So you can remap the whole thing, which is extremely powerful. Okay, so let's create a small setup with a growing vertex map, because this can also be done using the fields. So in the spherical field, we go to the remapping options and increase the inner offset and scale the whole thing down just to have some small point here. Okay, and then we go to the vertex map and create a freeze layer. So now everything that is underneath it, or everything that is currently giving a weight here, will be frozen. But the freeze layer comes with some more options. For example, the mode parameter, which can be set to grow. And let's see what happens if I hit play now. The whole vertex map grows. And this is something that doesn't just work with vertex maps, but also with MoGraph setups and everything else you can modify using the fields. So this grow mode is based on a radius. So it has a look at this radius parameter here. If I bring it down to 5 and hit play, it will have a look at every single point here, around one point that is weighted. And if it's within the radius of 5 centimeters, it will be weighted as well. So if I bring down this parameter here, you can basically control the speed of the effect. And here you see this is pretty much the minimum. And if I bring it down to 3, it will be a bit faster. So maybe let's bring that up to 10 again. And let's have a look at another tab here, which is called the radius tab. So the radius, which is used for the growing effect in order to control the speed, can be modified or can be weighted as well by using some other fields. This might be quite complex now, but it's also very powerful. So let's create a random field here. And let's set this random field to create some noise. Or maybe let's do this here. It's a separate object, which is very nice. Random mode, from random to noise. And Perlin is okay, but we will bring it up to like 400 maybe, or maybe 200 is enough. And now if we hit play, watch what happens. So we create a very organic effect here. And if we bring this, well, maybe down a bit. Yeah, you see that the noise is affecting the growth here. So growing effects are a big thing in Cinema 4D release 20 now. You can do all sorts of growth effects. Another thing you can do is you can modify directions. So let's open up another scene. The direction field here. Here we've got a spline, and the spline has a radius, and the spline is actually controlling the direction of these arrows, which are cloned, as well as the size. Yeah, this can also be done with a noise field, for example. So you can really control the directions with a noise. And areas that would be white are the areas where the arrows would point to, and areas that are black would be the areas where the arrows point away. All right. We are running a bit out of time because I want to show you some more features. But another thing that I want to show you with the fields is what you can use them for, or in which contexts you can use them. This is also a scene from one of our feature videos, but I added volumes here. So I've got one spherical field in this whole scene, and this controls the weighting for all of these things here, for MoGraph, for a deformer, for a vertex map, even for a polygon selection and a point selection and volumes. So let's move this field here. So right now you can see, okay, there must be a MoGraph effector, and I can show you. So actually there's a matrix object and there's a plane effector, and this one is controlled or masked with this spherical field. Then you can move it to the deformer. Maybe let's close this and go to the deformer. And you see there is a plane with a displacer on it. And in the fall-off tab of the displacer, because all of the deformers have fall-off tabs, there is the same spherical field. So it works here as well. It works in the MoGraph setup, but it also works in the deformer setup. Then let's go to the vertex map. I showed to you how this can be done already. So, oh, this is the wrong direction. It's the completely wrong object, actually. So here we go. We are controlling the vertex map here. We are also controlling a polygon selection. So what polygon selections have as well is a checkbox to use fields, same as in the vertex map tag. So you can even drive polygon selections with that. You can select every third or fourth polygon. You can randomly select polygons, whatever you want. And here in this point selection setup, I'm actually driving a point selection, and this point selection is used in order to drive bevel deformers. And then in the end, oops, wrong object again, you can also create volumes with that. But now I'm a step ahead because volumes is the next, and also unfortunately the last topic of this webinar. But here you see there are several contexts and a field can be used in all of them. So you can use some object, create a vertex map on this. With the vertex map, you drive a deformer and some shading, because of course we also have a vertex map shader. But you also create some clones on the object, and these can as well be controlled using this field in the end. So you've got one setup and you can use that in several contexts. Yeah, that's really powerful, and that's actually the feature I'm excited about the most, because it is so powerful. And once you really get how powerful it is, you can unleash a lot of potential inside of Cinema 4D or with your creativity. All right, the next and last thing I want to show you is volume modeling, and therefore I create a new scene. Maybe you even found it. Up here we've got a new menu entry which is called volume, and in there we've got a volume builder, a volume measure, smooth and reshape filters, and a volume loader. So what you can do is you can create models based on volumes. You can volume model objects. Unfortunately, with R20, it's not possible to render volumes as in smoke simulations or something. You can do that using a third-party renderer that supports OpenVDB, but for now we are just doing volume modeling here inside of Cinema 4D. Okay, so first let's create a volume builder, and you see that there is a list in the volume builder. And this list can be filled with objects, and those objects can be, merged together or subtracted from each other. You can make an intersection out of them. And it's like Boolean operations, but based on volumes. So first of all, there are two types of volumes, the signed distance field and the fog volume. The signed distance field is good if you want to really model something with it, because this describes a surface, so to speak. And the fog volume is something that you would use to create smoke or whatever you want, but you can also use it for modeling. I will show you a case how you can use it inside of Cinema 4D, which is also quite fun. Okay, what I want to create here is a screw. So screws are always difficult to model because they've got a thread, and actually threads are difficult to model. But with volumes, it's actually not that hard. So first of all, let's create a cylinder, and maybe let's bring the scale down and also increase the height segments. Maybe let's make the radius 25, so it's an integer number. And let's also create a spline, a helix spline. Let's make the plane X and C. Start radius as well as end radius should be 25. And the end angle should be, 720 times, let's say 5. Something like this. Okay, let's bring this down to this point. And now we need to make it sharp here at the end. So what we will create is a taper deformer, and let's make it a child of the cylinder and fit to parent. But let's also make it a bit smaller here. Turn it around and bring it to the bottom, like so, and then taper the whole thing, like so, 100%. And we copy this taper deformer over to the helix. So we've got this here. Okay, maybe, let's create some of the objects first. So the next thing should be a cone. We rotate it, bring it up and scale it down so that it looks like this. Then we create another cylinder, which should be the top part here, and scale this down a bit, like so. Let's bring this also down. Okay. And in the end, we want to create something like a cross for the top here. So let's scale this down, bring it up, wrong direction, scale this up, make it editable, and select the faces here in order to extrude them. But we don't want to preserve the groups, we just want to extrude, like so, and scale it down in Y direction, like so. And these are our object. Using these objects, we want to create the screw. So let's start with the cylinder. And the cylinder should be pasted just here inside of the list. So we drag and drop it down. And right now, it's the input type link. We can also delete it and make it a child of the volume builder. And this way it will also part of the volume, but the input type will be child. So keep that in mind. If you want to use one object in multiple volume builders, you can also just link them to the list here. So let's bring down the voxel size. This is the resolution of the whole thing, so to speak. Let's bring it down to 2, which should be still quite responsive. And let's also bring in here the helix spline. And now you see that there are points created on that helix spline. Let's bring that up a bit here. So you see there are some parameters here that you can adjust. Let's bring down the radius to 8 and maybe the density up to 1. So it's it's like a sweep. And then let's say that this shouldn't be added or unioned with the cylinder, but subtracted. And now we have this here. So this is our thread. So let's bring down the voxel size even more so you can see it better. Okay, now let's bring in the cone as well as the cylinder and also the cube with the cross here, but this should be subtracted again. So now they are all linked, but you can see that this is our screw now. So what else can we do here? We cannot just import objects. We can also smooth or reshape the whole thing. The smooth layer will, as the name says, smooth the surface here, and the reshape layer will move it in normal direction, so to speak. Pretty much everything is supported here. So you can throw in particles, splines, polygon objects, primitives, of course. You can even throw in hair or even fields, but I will show you this later. So for now, let's create a smooth layer. And there you see it creates the smooth based on a voxel distance. So if we bring that down, it will get a bit sharper again. So this is our volume for now, but it's not a model. So how can we polygonize this? Simply by creating the volume measure from the volume menu. And bam, now we are done. So simply create some new node material, maybe the metal one, apply it, and there you go. This is the screw. Okay, if we have a look at the topology here, it's quite dense. It's all quads, but this is a typical VDB mesh. But we can make adaptive tessellation here, or apply adaptive tessellation here in the volume measure, so we can bring that up. But in my opinion, it's best if it's somewhere around 2 centimeters, 2%. And there we go. This keeps the details, but also reduces the amount of polygons a lot. So here you've got a screw that was created within 5 minutes. And imagine modeling this by hand. It would take much longer. Okay, the next thing I want to show you is how to mesh a noise, because this can also be done with Cinema 4D Release 20. First of all, we create a field, which should be the random field. We set the random mode to be noise again, adjust the noise type to be SEMA, and it should be much bigger, maybe 2000. And there you see, this is SEMA noise. Maybe even bigger, 4000. Okay, now let's create a volume builder, and let's set this to fog, because fields work better in fog mode. Just place the random field here, and you can already see that there is some colorization going on. Once I bring down the voxel size here, maybe to 3, you can see that there is a quite good 3D representation of this noise. And this is also what we can mesh. So with the random field, you know, you've got weights with fields. So everything that is black is 0% and everything that is white is 100%. And yeah, at some point, yeah, you define a threshold where to create the geometry, and this will be done in the volume measure. Here you can do that. And yeah, so this is a meshed noise. Of course, you can go higher on the resolution, but I want to show you something else. If you hit play here and adjust the random field to have animation speed, you can see that you can also animate the whole thing. And this opens up a whole new way of creating motion graphics or abstract animations in general. So yeah, this is actually what I wanted to show you. One last thing that I show you in a new scene is that you can also import volumes. Here I've got a bunny VDB, which is the Stanford bunny, and I can just drag and drop it in here, and there's the volume import dialog. We leave it as is, press OK, and there we go. This is the Stanford bunny, or a volume of the Stanford bunny, and select it and use the volume measure with Alt, so it's automatically a parent object of the imported volume here. So, all right, that's basically it. I want to show you some images here. So this is something that you can do with volume. So there is some, well, CAD imported thing, and this is turned into some dual mesh setup here, but it's all one geometry. So it's very nice. This is also another example for creating, machine parts. And the volume modeling can be used in 3D printing extremely well. So this is also created using volume modeling. Or this, as seen by Jan G. Or this one. Yeah, that's basically it. That's what I wanted to show to you. And I hope you liked this short presentation of Cinema 4D Release 20. Thanks for being here. Thanks for being Cinema 4D users. And we are really happy to have you there. And we are also really excited about what you will come up with when you have Cinema 4D Release 20 in your hands in September. All right. Have a nice day, guys. Bye.